Hello everyone, this is Rakshita from Artificial Intelligence and Data Science Department, first year A section. So in this video, we are going to see the experiments for the Dsd Lab. So the first experiment is the study of logic gates. In this experiment, we will learn about the implementation of AND gate, OR gate, NOT gate, NOR gate and NAND gate. And we will also see the implementation of a 3-input NAND gate. In the second experiment, we will do the study of adders and subtractors, which is the half adder, full adder, half subtractor, and full subtractor. Next, in the third experiment, we will see the code converter, which is binary to gray code and gray code to binary. And in the fourth experiment, we will see code converter 2, which is BCD to XS3 and XS3 to BCD. And in the fifth experiment, we will see the parity generator, which is odd parity and even parity. In the sixth experiment, we will see the study and implementation of multiplexers and demultiplexers, which is the 4-to-1 multiplexer and 1-to-4 demultiplexer. Then in the seventh experiment, we will see encoders and decoders. So in this experiment, we have taken an 8-to-1 encoder and a 2-to-4 decoder. So let us see the first experiment. So this is the first experiment, which is the study of logic gates. So here we can see how to implement multiple logic gates like AND gate, OR gate, NOT gate, XOR, NAND, NOR, etc. So first we are going to see how to implement the AND gate. So the two toggle switches are taken as the input and a light bulb is given as the output, and this is the AND gate. So first we have to connect the toggle switch to one end of the AND gate and another toggle switch to another end of the AND gate, and connect the AND gate to the light bulb, which is the output source. So when the toggle switches are off, the inputs are 0 and 0. So when the inputs are 0, the output is 0. If the light bulb glows, then the output will be 1. Then if the inputs are 0 and 1, then the output will be 0. Then if the input is 1 0, then the output will be 0, and if the inputs are 1 1, then the output will be 1. This is for AND gate. Next, for OR gate, if the inputs are 0 0, the output will be 0. If the inputs are 0 1, the output will be 1. If the inputs are 1 0, the output will be 1, and if the inputs are 1 1, the output will be 1. Then the NOT gate performs the inverse of the input. So if the input is 1, then the output will be 0, and in this case if the input is 0, the output will be 1. So if the input is 1, then the output is 0, as the light bulb does not glow. Then this is the XOR gate. So for the XOR gate, if both the inputs are the same, then the output will be 0. For example, the inputs are 0 0, then the output is 0. If the inputs are 0 1, the output will be 1. If the inputs are 1 0, the output will be 1. If the inputs are 1 1, then the output will be 0. That is for XOR gate. Next is the NAND gate. It performs the inverse of the AND gate. So if the inputs are 0 0, the output is 1. If the inputs are 0 1, the output is 1. If the inputs are 1 0, then the output is 1. And if the inputs are 1 1, then the output is 0. Next is the NOR gate. So for the NOR gate, it performs the inverse of OR gate. So if the inputs are 0 0, the output is 1. If the inputs are 0 1, the output is 0. If the inputs are 1 0, then the output is 0. And if the inputs are 1 1, then the output is 0. Next is the 3-input NAND gate. So here all of the gates we saw, there are only 2 inputs, but this is a 3-input NAND gate. So it requires 3 inputs, that is 3 toggle switches. So if the inputs are 0 0 0, then the output is 1. If the inputs are 0 0 1, then the output is 1. If the inputs are 0 1 1, then the output is 1. If the inputs are 1 0 0, then the output is 1. If the inputs are 1 0 1, then the output is 1. Then if the inputs are 1 1 1, then the output is 0. and if the inputs are 1 1 0, then the output is 1. So this is the 3 input NAND gate. We can verify the output by using the truth table for all of these gates. So this is the second experiment, which is the study of adders and subtractors. So this is the half adder and this is the full adder. Well, this is the half subtractor and this is the full subtractor. So first let us see how half adder works. So generally in half adder and half subtractors, we have two inputs and two outputs. So for a half adder, we have two inputs A, B, for example, and two outputs, which is the sum and carry. So the first light bulb is for sum and the second light bulb is for carry. So when the inputs are 0, 0, the sum will be 0 and the carry will also be 0. When the inputs are 0, 1, the sum will be 1 and carry will be 0. When the inputs are 1, 0, the sum will be 1 and carry will be 0. And when the inputs are 1, 1, sum will be 0 and carry will be 1. So this is how a half adder works. And for a full adder, you will use 2 XOR gates, 2 AND gates and 1 OR gate. And you will need 3 inputs and you will get 2 outputs, sum as usual, sum and carry. So when the inputs are 0, 0, 0, you will get sum 0 and carry 0. When the inputs are 0, 0, 1, you will get sum 1 and carry 0. When the inputs are 0, 1, 0, you will get sum 1 and carry 0. When the inputs are 0, 1, 1, you will get sum 0 and carry 1. When the inputs are 1, 0, 0, you will get sum 1 and carry 0. And then when the inputs are 1, 0, 1, you will get sum 0 and carry 1. Then when the inputs are 1, 1, 0, you will get sum 0 and carry 1. And finally, when the inputs are 1, 1, 1, you will get sum 1 and carry 1. So this is the truth table for full adder. Next we are going to see for half subtractor. The same like full subtractor, a half subtractor also has two inputs and two outputs. In full half adder, the outputs were sum and carry, whereas in subtractor, it will be difference and borrow. So first is 0, 0. When the inputs are 0, 0, you will get the difference as 0 and borrow as 0. Then when the inputs are 0, 1, you will get difference 1, borrow 1. Then when the inputs are 1, 0, you will get difference 1, borrow 0. And the inputs are 1, 1, you will get difference 0, borrow 0. Then this is the full subtractor. So for full subtractor, like full adder, you will have 3 inputs and 2 outputs, difference and borrow. So the inputs, when the inputs are 0, 0, 0, the difference and borrow will be 0, 0. When the inputs are 0, 0, 1, the difference and borrow will be 1. When the inputs are 0, 1, 0, the difference and borrow will be 1. When the inputs are 0, 1, 1, the difference will be 0 and borrow will be 1. When the inputs are 1, 0, 0. So when the inputs are 1, 0, 0, the difference will be 1 and borrow will be 0. When the inputs are 1, 0, 1, difference will be 0, borrow will be 0. When the inputs are 1, 1, 0, the difference will be 0, borrow will be 0. And finally, when the inputs are 1, 1, 1, the difference will be 1 and borrow will be 1. So this is how a full subtractor works. This is the second experiment. All of this can be verified by using the truth table. So this is the BCD to XS3 converter. So generally BCD, when it converts to XS3, you have to add the input with 3 and that will be your output. So for example, when your input is 0, 0, 0, 0, your output should be 3, which is why the second and third light bulb glows. As the first light bulb is equivalent to the value 8, the second is equivalent to the value 4, and the third is equivalent to the value 2, and the fourth is equivalent to the value 1. It follows the 8421 code. So when your input is 0, 0, 0, 0, the output will be 3, so your second and third light bulb glows. When your input is 0, 0, 0, 1, which is equivalent to 1, 1 plus 3 is 4, so your second light bulb glows. When your input is 0 0 1 0, which is equivalent to 2, 2 plus 3, which is 5. So your light bulb, which is equivalent to the value 4, and the light bulb, which is equivalent to the value 1, glows. Then the same way, when your input is 3, that is 0 0 1 1, the second and third light bulb glows. Then when your input is 0 1 0 0, your first 3 light bulb, your last 3 light bulb glows. Then when your input is 0 1 0 1, your first light bulb glows. Then when your input is 0 1 1 0, then your first and last light bulb glows. Then when your input is 0 1 1 1, your first and third light bulb glows. Then when your input is 1 0 0 0, when your input is 1 0 0 0, which is equivalent to 8, 8 plus 3 is 11, so 8, the light bulb, which is equivalent to the value 8 plus the value 2 plus 1, it glows, as 8 plus 2 plus 1 is equal to 11. Then when your input is 1 0 0 1, your light bulb equivalent to the value 8 and the light bulb equivalent to the value 4 glows, as 9 plus 3 is 12. So as we are converting from BCD to XS3, the values after 9 will be taken as don't care condition. So this is the fifth experiment, which is the parity generator. So in this experiment, we have 3 inputs and 2 outputs. So the first output is for odd parity and the second output is for even parity. So when your inputs are 0 0 0, your odd parity will be 1 and your even parity will be 0. When your inputs are 0 0 1, your odd parity will be 0 and your even parity will be 1. When your inputs are 0 1 0, your odd parity will be 0 and your even parity will be 1. When the inputs are 0 1 1, your odd parity will be 1 and even parity will be 0. So when your inputs are 1 0 0, your even parity will be 1 and odd parity will be 0. So when your inputs are 1 0 1, your odd parity will be 0, your odd parity will be 1 and your even parity will be 0. Then when your inputs are 1 1 0, your even parity, odd parity will be 1 and even parity will be 0. And then when your inputs are 1 1 1, your odd parity will be 0 and your even parity will be 1. So this parity generator is implemented with the help of 2 XOR gates and 1 NOT gate. So this is the sixth experiment, which is the design and implementation of multiplexer and demultiplexer. So in this you will have 4 data inputs, D0, D1, D2, D3 and 2 selective inputs, S0 and S1. So first, when your selective inputs are 0, both the selective inputs are 0 and your D0 is 1, the output will be 1. Then when your selective inputs are 0, 1 and D2, D1 is 1, then your output will be 1. And then when your selective inputs are 1 0 and your D2 is 1, your output will be 1. And then when your selective inputs are 1 1 and D3 is 1, your output will be 1. So this is the working of a multiplexer, a 4 to 1 multiplexer. So this is the demultiplexer. This is a 1 to 4 demultiplexer. So the same as multiplexer, it has 2 selective inputs, S1 and S0, and it has 1 input. So first when the input, and it has 4 outputs. So first when the inputs are 0 0 0, your outputs will also be 0 0 0. When your inputs are 0 0 1, your outputs will be 1 0 0 0. Then when your inputs are 0 1 0, your output will be 0 0 0 0. Then when your inputs are 0 1 1, your output will be 0 1 0 0. Then when your inputs are 1 0 0, your output will be 0 0 0 0. Then when your inputs are 1 0 1, your output will be 0 0 1 0. Then when your inputs are 1 1 0, your output will be 0 0 0 0, and when your inputs are 1 1 1, your output will be 0 0 0 1. So the seventh experiment is the implementation of encoders and decoders. So this is an encoder. It has 8 input lines and 3 output lines. So it has 2 power 3 input lines and 3 output lines. So first, if your input is 1 1 0 0 0, your output will be, so this is D naught. D naught will always, D naught or E naught, it will always be 1. So there's no connection made for the first toggle switch. So we are considering from E1, E2, E3, E4, E5, E6 and E7. So when your E1 is 1, your third light bulb glows. Then when your inputs are 0, 0, 1, 0, 0, 0, your second light bulb glows. Then when your inputs are 0, 0, 1, 0, 0, then your second and third light bulb glows. Then when your inputs are 0 0 0 1 0 0 0, then your first light bulb glows. Then when your inputs are 0 0 0 0 1 0 0, your first and third light bulb glows. Then when your inputs are 0 0 0 0 0 1 0, then your first and second light bulb glows. And then when all the inputs are 0 and the last input is 1, all the 3 light bulbs glows. You can verify your output with the help of truth table. So this is a 2 to 4 decoder, and in this there are 2 inputs and 4 outputs. So first, when your inputs are 0 0, your output will be 1 0 0 0. When your inputs are 0 1, your second light bulb glows, so the output is 0 1 0 0. When your inputs are 1 0, then your third light bulb glows, so your output is 0 0 1 0. Then when the inputs are 1 1, your fourth light bulb glows, so your outputs are 0 0 0 1. So this is the implementation of a 2 to 4 decoder. Generally a decoder takes 2 input lines and produces 2 power n output lines.